The correlation between electronic polarizability and ionic polarizability is mu E is for electronic polarizability and mu I is for the ionic polarizability. And already we are familiar with the relation mu is equal to alpha is equal to mu by E. For ionic polarization, that is mu I by E, and we correlate this, then we get E square by omega naught square 1 by small m plus 1 by capital M. So this polarization is for ionic polarization. Applied electric field for this polarization is 10 power 13 Hz, and for electronic 10 power 15 Hz, and this is in the range of IR, that is called as the infrared radiation. It is the slower process when compared to that of electronic polarizability, and this polarization is also independent of temperature. Both electronic and ionic polarizabilities are independent of temperature. Next polarization is for the molecules. So we are correlating all polarization in atoms, polarization in ions, and polarization in the molecules. This is also called dipolar polarization. Another name is molecular polarization. We observe this polarization in H2, N2, O2, Cl2, CH4, and CCl4. All these are the molecules. They does not carry any dipoles because the center of positive charge and center of negative charge will be get coincides. Positive and negative charge gets coincides, then the metal is non-polar. On the other hand, the molecules like this ethyl acetate, they are carries the dipole nature even in the absence of the electric field. So some of the materials will be get polarized with the presence of the field. Some of them has application of the polar natures without the absence of the electric field itself. However, the net dipole momentum is negligibly small since all molecular dipoles are oriented randomly without EF. EF is the applied electric field. In the presence of electric field, then all the dipoles will rearrange themselves. So some of the molecules has dipole nature in random and some of the dipole in the regular direction itself. So this is the expression for the orientation polarization. O refers orientation polarization. So this refers N. Here N indicates that we can polarize N molecules. Mu orientation. If we combine this relation with original relation, mu is equal to the relation which we discussed, that is mu square by 3 kt. Then we get a relation in the form of n alpha naught E. Here alpha naught is the mu square by 3 kt. So this is the combination of three types of polarizations. Already we referred electronic polarization, ionic polarization, and orientation polarization. In combination we get it as Langevin-Debye equation, that is alpha. So here 4 pi epsilon naught r cube is for electronic polarization, and E square by omega naught square 1 by capital M plus 1 by small m is for ionic, and mu square by 3 kt is for the orientation polarizability. Combination of all these is called as the total polarizability. Later, another topic which we learn in our present lesson is internal fields. Another name for internal fields is the local fields. So here we discuss this as the Lorentz derivation. Now, evaluation of the internal field. Let us consider a dielectric material and place this dielectric material between the parallel plate capacitors, because this is the application of this dielectric material. We use this dielectric material as the vacuum oriented place in between the capacitor parallel plates. So here dielectric material is considered as the atom when it is placed inside the dielectric. Let us consider a single atom. The shape of the atom is spherical. So this is about the shape of the atom which is placed around the capacitor parallel plates, and which this is connected to the electrical battery positive. This gets positive charge, and this is connected to electrical battery negative, which is a spherical cavity. Here atom is a spherical cavity. So due to placing in between the two capacitor parallel plates, originally atom has positive and negative charges in coincidence, and due to this polarization both of the charges will be get separated. Here electric field present inside the body is constituted into four forms. They are E1, E2, E3 and E4. So inside the body we discuss four types of internal electric fields. The first field is E1. It is the field intensity at the atom due to the charge density on the plates.